the authors have a short section on trophic effects on nutrient cycling. They state that herbivores enhance the productivity of productive ecosystems and reduce the productivity of unproductive ones. Now from the outset, I'm going to state that there probably are as many exceptions as far as ecosystems are concerned as there are ones that follow the rules. But what they want to get across is some of the importance of the feedbacks that exist when herbivores consume plants as far as nutrient cycling is concerned. Figure 10.9 shows the major points that they would like to make here. On the x-axis, we essentially have a soil fertility gradient, and we're going to have two different systems. We're going to have a low and a high fertility system, one that nutrients are not that abundant, and ones where it's relatively high. So what happens when we look at a low fertility system? Well, most of the plants that are there tend to grow relatively slow and have a high allocation of plant defense, and these tend to be the carbon-based plant defenses rather than the nitrogen-based ones. As such, we tend to have relatively slow decomposition in those systems, and that slow decomposition often reinforces low soil fertility. So you have a situation where you can get a positive feedback from low nutrient availability to slow growth, lots of well-defended plants that slow decomposition even further and reinforce low fertility. What happens when you have herbivory on a low fertility soil? So in those cases, you can have relatively high fertility plants or plants that grow fast, aren't well defended, and are good to consume in those systems, but those tend to be selected out. And so in this case, you're going to have plants, for example, that are good to consume from herbivores that might be within the system too, but they're selectively eaten by herbivores, which reinforces the cycle here of slow-growing, well-defended plants, low decomposition rates, and low nutrient availability. When we move over to high fertility soils, you can see that the plants that are often present here are going to have rapid growth, and they're not going to be defended that well. And again, here, it's really the carbon-based defenses that they're talking about for low plant defense. In those cases, you can have lots of herbivory, for example, and when herbivores eat plants, they speed up the decomposition of that material, in essence, and return nutrients to the soil in the form of feces and urine. That speeds up the nutrient cycle and increases fertility even greater. Also in this system, if you don't have grazing, or for those plants that aren't grazed, they're not defended well, they tend to have high nitrogen concentrations and are decomposed relatively quickly, which further reinforces high soil fertility. So in this case, having grazing or herbivory in this system can actually speed up the nitrogen cycle and maintain high soil fertility. Now, the dividing line between these two systems, for whether it's a low soil fertility or a high soil fertility system, the number that they give, it's about 1.5% nitrogen. And again, if you think about herbivores, that often 1% nitrogen is a good cutoff for maintenance levels of nitrogen that they require, and 1.5% is above maintenance levels. And having plants that have 1.5–2% nitrogen, it's usually enough to keep it a fertile system where a large proportion of the plants can be consumed. So when we think about these different ecosystems and trying to come up with generalizations for how herbivores impact nutrient availability, in our very simple system of having plants and herbivores, we tend to think of the transfer of energy. But there's also materials that are transferred too, such as nitrogen and phosphorus. And in this case, what herbivores do with it sometimes is they'll return those nutrients, such as nitrogen, back to the soil. Now, whether a system having herbivores speeds up the nitrogen cycle, for example, and increases nutrient availability to plants, or whether it decreases it, is relatively complex. I think the example that they give is not necessarily going to be a generalization across ecosystems, and you can see that they didn't necessarily have data to show that this was a generalization. But it's important to know that there are feedbacks that occur as far as nutrient availability is concerned, and herbivores, through their actions, can sometimes slow down the cycling of nutrients, and sometimes speed it up.